everyone, welcome to the first video of Statistics series. In this series, we will particularly cover statistics from the point of view of entrance exams. The first topic we will be covering is central tendency. Central tendency is divided into two parts. First is numerical averages and second is positional averages. Numerical averages covers arithmetic mean, geometric mean, harmonic mean, and positional average covers median and mode. As we go further, let's first understand what is numerical average. A numerical average is particularly suitable for only numeric data. Let's focus on the very first one, which is arithmetic mean. Arithmetic mean is fairly very simple. It is sum of all observations divided by number of observations. Let's talk about one of the most important properties that arithmetic mean possesses, which is the mathematical treatment property. This property says that if we combine two different datas with mean x1 bar, x2 bar and number of observations of x1 bar mean is n1 and the other one is n2, then the mean of the combined data set, which is x bar, will be this. That is n1 x1 bar plus n2 x2 bar upon n1 plus n2. Next, another important property that mean possesses is it is affected by both change of scale as well as origin. So, if each number in a data set is first multiplied by a and then b is added, this is change of scale and this is change of origin, then the new arithmetic mean will also be a times of x1 bar, which is the prior mean, plus b, which is the change of origin. We will also understand this by an example just below. So let's say a, which is the change of scale, is 2 and change of origin b is 1. So first I will take the data set 1, 2, 3, 4, 5 and if I multiply this with 2 and add 1, I will get 3, 5, 7, 9 and 11. Earlier, the arithmetic mean of this data would have been 3. However, since there has been a change of scale and origin, the new mean looks like this, which is 7, which can also be obtained if I multiply the prior mean, which was 3, with 2 plus 1, and we get 7. Hence, we just proved that it is affected by both change of scale and origin, and the new mean is simply a times of prior mean plus b. Now let's come to another important property that arithmetic mean possesses, which is the sum of deviations from mean is always 0. Let's also understand this with the help of example. Let's take this as our data point 1, 2, 3, 4 and 5. So arithmetic mean will be sum of all observations divided by number of observations, which comes out to be 3. Now, sum of the deviations. When we say sum of the deviation, it means if from each observation we subtract the mean value and then sum it all over, it should come out to be 0. This is what we mean by this statement. So if I do that, if I subtract mean from each of the observation, I get -2, -1, 0, 1 and this will be 2. And if I add all of this, I get a 0. Hence, we proved another important property of arithmetic mean, which is that sum of deviation from mean is always 0. Also, another important property to note is that some square of deviations is minimum around mean. So when we say some square of deviations, it is simply summation of xi minus x bar whole square. It says that whenever we have x bar here, then that deviation will be minimum. If instead of arithmetic mean, let's say we use median, then this value will always be greater than sum of deviations around mean. If you have any questions, you can post it in the comment section and I'll be very happy to answer. Thank you for watching.